Spock is at the science station. He proposes a way to detect cloaked ships, and he uses gravitational microlensing. Is this possible?
The ship in question appears to have a kind of cloaking device. By detecting the microlensing of background stars, we can determine an approximate location. They still have a detectable gravitational presence. The ship in question...
Okay, can you slow it down for me, break it down?
So gravitational lensing, as far as I understand, is if we got a picture here. If the bottom left is Earth, and then in the middle, in that big glowing ball in the middle, is some huge galaxy.
Big.
And then the other picture, it's this disk. That's a whole bunch of galaxies really far away. So the light comes off these really, really far away galaxies, bends around the galaxy in the middle, and comes to Earth.
I see. So there's three objects in a line. There's the Earth, the galaxy that is in the background shooting light towards the Earth, and that light should be obstructed by this galaxy in the middle, the lensing galaxy. But instead, the light from this faraway galaxy gets curved around this intermediate galaxy, just like light in a lens.
Mm-hmm. And so this has been observed with telescopes. If we go to the left a little bit more, this is what it looks like. So like the top one is like the best example of like the light comes from the galaxy behind in all directions. The center bright dot is the galaxy that's doing the bending, and this like blue circle is the galaxy that's been warped by the lensing, and it shows up as a circle. Because
for this not to be a gravitational lensing event, this would be some type of stringy, almost circle like galaxy. That's unphysical. That doesn't make any sense.
Right. And then sometimes the lensing isn't perfect, and so you can get these like nodes, which is the lower picture, where it's like not a perfect ring. It's actually like bright spots. But it's the same idea. That's the center. It's doing the bending, and then the four bright spots are the galaxy behind.
If I remember, it's been a while. If I remember, you have to discount the possibility that this just happened to have been four galaxies lined up like this. But if you look at the signatures from these galaxies, they all have the same signature, which suggests not that they're four different ones, is that they're actually the same galaxy imaged four times.
Right. So I guess there's a whole bunch of scientific details that we're skipping over just to determine that it's truly lensing and not actually an object out there.
But if I can say one more thing here, so the light is coming from the faraway galaxy. It's taking this white path. It gets bent around the lensing galaxy, and from Earth's perspective, we see it as if it's coming from this orange path. That's so that you see an image of a galaxy there, a second image galaxy there, and in a really good, really lined up scenario, you get almost a ring.
Yeah. So Spock is proposing that instead of using a whole galaxy to bend light, we're going to use the tiny, tiny, tiny mass of the ship, the cloaked ship, to do the lensing for us, and he's going to bend the light of the background stars.
Oh boy.
So this gravity is super weak, so weak. And you got this tiny, tiny, tiny ship. I mean, it is tiny in comparison to stars and galaxies. And so the light's going to come in from faraway stars and bend ever so slightly around the ship. I mean, the sensitivity of these sensors to detect that kind of bending. I mean, it's probably smaller than the size of an atom. It's probably such a tiny amount of bending due to the lensing effect. Like, wow.
We need a couple things here. One is that you need the mass of a galaxy to bend the space-time, really curve this light. The second thing is you need propagation distance. You need distance for this light to travel. Like if you were way up in here, do you have enough distance for that light to bend, or is it like it's past you don't even see it?
Right. So you have these tiny deflection angles, and those tiny deflection angles need a huge amount of distance to create differences in propagation. So, gosh, we have huge galaxies and huge distances when we detect gravity lensing on Earth. And he's proposing to do it on a intrasolar system scale with a tiny, tiny ship.
A tiny little baby ship.
The Federation sensors are off the charts.
Okay. But he says microlensing. It says
does say-
microlensing. So
it's like-
that's right. But
It's like hella femtolensing, because
it's some scientific. It's some SI prefix that I don't know if it exists.
yeah, because it would be so exceptionally tiny,
Doesn't exist in our timeline.
right? Gosh. We should
Hey.
it'd be interesting to run some numbers for this just to see how tiny the numbers actually are. But just my intuition is saying this is unbelievable.
So maybe we can do the exercise of what would we need to know. We would need to know the mass of the Romulan ship. We would need to know how far it is.
Mm-hmm.
I think that's it.
Well, I guess for the detector itself, you would have a background. Oh, I have a background of stars.
Hey,
Look at that. I have background of stars, and I put a ship in between, and I have light coming off, and it's going to bend.
Yep.
And all I need to see is as the ship moves, it slowly warps the background of stars. This is the warping.
a little crab in space.
But if we wanted to estimate what that warping would be, we need to know the mass and the distances, I think.
Okay. Wait. But I think you figure out the distance by the angular, the curviness. You just need to know the mass, but we don't know the mass of the Romulan ship.
Right. So as a detector, you don't know the mass or anything, but if you're looking for that warping as the ship goes by, then you can say, oh, it's a ship. Follow the warp. But if you did know the mass of the ship and you did know the distances, you could estimate what the warping would be. So you know what to look for. I think there's sort of two parts to that. You know what I'm saying?
I think so. I think so. So
But
maybe in principle this works, but the sensitivity of the equipment on the Enterprise must be incredible.
maybe this is something we could dive deeper in on the Science Channel. Maybe.
Good. Okay. Good.